Hi, thanks very much for watching this video on the proposals for sequencing which are coming out of LETSI. My name's Crispin Weston. I'm chair of the LETSI orchestration working group, and I'm also chair of Soltis, which is a group of companies in the UK addressing interoperability in schools, or K through 12. First, let me explain the basic idea of sequencing in case you're not familiar with it. If you see learning content, and by content I don't just mean information but also activities and tools. If you see those activities as a whole pile of Lego bricks, then sequencing is what happens when an instructional designer, maybe a publisher, builds those activities up into a course or a lesson or a work plan or whatever context-dependent name you want to give to the content aggregation. The idea behind interoperable sequencing, and I would argue behind content packaging itself, is that the teacher or some other intermediary should be able to take that course supplied by the publisher, to take it apart, to disaggregate the content back into its component activities, so that those activities can then be resequenced in order to create something else, to apply the same learning activities, perhaps to a different context. And if it seems like a formidable task for an ordinary classroom teacher to take a huge pile of disaggregated bricks and build a complex course out of it, well, maybe that's taking the model a little bit to an extreme. Maybe a more likely use case is for the teacher to take the course provided by the publisher and just modify it, tweak it a little bit to suit the teacher's own particular context. When LETSI met at a technical workshop in Pensacola in October 2008, there was a very general view that current sequencing models weren't working very well. But there were broadly two different views on what needed to change, and we feel that those two views reflect two slightly different communities of practice which are commonly using this technology at the moment. Corporate training normally has a single instructional design team creating courses for a single set of students. As there's only one intended use of the course, object reuse is not a priority. In this scenario, instructors normally play a supporting role and do not have authority to modify the course. The course therefore has to control student progress automatically, and the functionality, complexity, and the size of such courses is often very demanding. Corporate training is therefore normally demanding of functionality, but not demanding of reuse. The situation in schools, or K through 12, is very different. Here, many different publishers supply materials to many different teachers, delivering content in different circumstances to different types of students. Teachers are not only administrators of the course, but also course designers, and are rarely happy to administer a single publisher's course without intervention. But because the administration of the course is managed principally by the teacher, the requirement for very large, complex sequences is much less. Normally the teacher will want to sequence a few materials for a lesson or a homework. The K through 12 case, therefore, requires robust object reuse, but has less emphasis on complex functionality. So it's perhaps no surprise that what came out of our discussions was a twin-track approach, which mirrors the two different priorities of corporate training and K through 12. The declarative track aims to produce a spec in the same space as simple sequencing, something that could, for example, be included within an IMS content package. It aims to be much simpler to implement than simple sequencing, but does not necessarily aim to cover the most advanced forms of instructional design. This latter piece will be covered by the delegated track. The LMS will here be able to delegate any sort of orchestration to a third-party service, which can use whatever internal implementation it likes, BPEL, SCXML, ECMAScript, proprietary code. From the point of view of the non-technical teacher or instructional designer, what the delegated approach would offer would be reusable templates, developed by whoever, allowing you to plug your own learning materials into that template, maybe using authoring tools created by the template designer. So the delegated model is a little more challenging to implement initially, but once you're over that hump, it offers a very powerful and extensible sequencing model. I'm now going to take a couple of slides to give you an overview of our thoughts on the declarative model. The leading specification in this space, as I've already mentioned, is simple sequencing. Simple sequencing is built on an assumption which is made in IMS content packages that the activity tree represents a kind of table of contents, a sort of hierarchical menu which will be displayed to the student and which allows the student to browse through the course at will. But that's a very different model to the assumption which lies behind much flow-based sequencing, which is that the student should be constrained to do first one activity and then another activity. So we felt that a lot of the complexity in simple sequencing could be traced back to the attempt to integrate these two basically incompatible models. Our proposal starts from the assumption that each cluster within the hierarchy might represent a different model or pattern, and that patterns can be nested within each other, providing flexibility. Attributes attached to the cluster parent establish the pattern which should be applied to the children. So here the yellow cluster is declared to be sequential, which means that the child items of that yellow parent will be launched one after the other, with no backtracking allowed. The green cluster presents the student with a menu with two choices. And if the student chooses the second of those two choices, he gets in fact a random selection from the children of the third purple cluster. The implementation of the pattern principle is very simple. It requires a single XML element with a single attribute. Based on that simple but flexible foundation, it's easy to add more complexity if you want. Some nodes could be marked with entry conditions, which determined whether an item should be skipped or disabled, depending on some conditions such as user role, performance, or competency. In the case, for example, of menus, you may want to allow the user to make several choices and control whether they can choose the same item twice. You may wish to allow the sequence author to control flow by creating and modifying custom variables. This extends the model to become a simple programming language. You may wish to allow the sequence author to show messages to the student to let him know how he's getting on, what's coming next, etc. These messages can have embedded variables so that they're context dependent. This slide gives an overview of how the delegated model would work. The orange and green items reference learning objects, or what SCORM would call shareable content objects, or SCOs. The pink object references what we're calling an orchestration manager object. This does not itself deliver learning, but orchestrates objects or components that do. It could also, of course, orchestrate other nested orchestration managers. The essential characteristic of this approach required for object reuse is that the orchestration manager does not know until runtime what it's orchestrating. So there needs to be a modification to the runtime protocols to allow this information to be passed. At the same time, you need to ensure that you're asking the orchestration manager to orchestrate objects which are appropriate to it. We therefore envisage typing schemas, a schema which an individual developer could create to list the different types of object which the orchestration manager can accept. These schemas would probably be stored on a publicly available repository. LETSI is now looking at putting these proposals into practice with a very simple proof of concept trial, which we want to get going in the autumn of 2009. A very simple implementation of the declarative model, maybe using only the pattern attribute, is an obvious first step for both tracks. It provides the basis for the delegated approach, because as well as sequential, choice, random, and concurrent, one of the patterns you could implement would be delegated. So having implemented a prototype of the declarative approach just at pattern level, we will be in a better position to test user demand for a development of the two alternative approaches. It may be that at that stage, effort would be switched into the delegated track. If you're interested in getting involved in that proof of concept trial, as an LMS implementer, a packaging tool provider, or as a learning content publisher, please get involved with our work by emailing info@letsi.org. If you have any questions or reactions for me, or if you're a supplier of learning technology to UK schools, please send me a line at crispin.weston@alphalearning.co.uk. Thank you very much for listening.